Hello, everyone. Welcome to a session, hopefully, that will be very informative and interesting to you. This presentation is not trying to insult you by calling you a dummy. Instead, it is in the same vein as the books that are the black and white books that you can find in the bookstore that say anything for dummies, just assuming nothing and starting from ground zero to learn about a component. So this one is learning about a component in ZOS called ZOS BCPii. So we're going to be focusing on that for the next hour. If you have any questions, you feel free to ask, and I will try my best to answer. So let me just tell you a little bit about myself. My name is Steve Warren, and I work in IBM Poughkeepsie in the United States, and I was a ZOS developer for many, many years. And in the last 9 months or so, I work in the Client Center. And the Client Center to, again, provide us new solutions for clients and helping them guide their way to embrace new technology on the Z platform. So that's where my background is. And with that, I am the founder of the BCPii component. So I sort of created this component and was the team leader for many, many years in this component. And so hopefully, I will be able to impart some of my knowledge to you about this thing, okay? So our agenda, we're first going to focus on the mainframe overview, and this may seem like a little redundant, but to level set everyone about the parts of the insides of the mainframe that BCPii interacts with, I think it's important to make sure that we're all talking about the same thing. So we're going to talk just a little bit about some basic mainframe concepts. Then we're going to say, what is BCPii and why would I want to use this? And we'll talk about, from a standpoint both of the operating system and vendor applications that use BCPii to actually be able to interact with the hardware. We'll also then talk about just some real basics about writing BCPii applications. Some of these topics are standalone topics by themselves, but we'll just give you an overview of how you can actually do that and how many clients have written applications and some of the kinds of things that they do using BCPii. Then we'll talk about installation just in a very high level overview. How do I install and activate BCPii so then you can actually run it in your shops? And then finally, just very primitive stuff about operations and debugging. How do I maintain this thing that I've started? Okay, so that's where we're going for the next hour, okay? All right, let's talk a little bit about the mainframe overview, and we're going to talk a little bit about the evolution of mainframes. So you can see here there's a lot of generations of machines that have come out over the last number of years. And with each one of these machines, there's been a need to automate some of the configuration and particularly in the hardware space for being able to programmatically automate the configuration of these systems and to be able to do operations from a hardware perspective in a more automated fashion. So we'll talk a little bit about that. So you see the generations of these boxes. You start out with the Z9 box there on the left-hand side, and then you move across, and then until you are at the Z13 on the far right. I'm sorry, the Z14 processor, and then the latest evolution of that is just recently announced, just a short time ago, and that's the IBM Z15. And of course, there are many models here, and this is just a sampling of two of them, a 1-frame wide unit, which is 19 inches wide. It fits in a standard rack. And then you have the 4-frame unit as well. That's the big mama, the largest configuration that you can have for that. All right, so if we just look inside a little bit, there's all kinds of stuff inside that, okay? And you don't really need to know a lot of the details about this. The most important thing we're going to talk about, not the most important thing in the box, but the most important thing from a BCPii perspective is going to be this thing in the upper right corner called the support elements. But we'll first talk about the fact this is, in this 4-frame unit, this is fully it's filled to the max with all kinds of stuff. And if you look on both extreme left and right sides, you'll see that there are lots of PCIe and I/O drawers. This allows the connectivity to the mainframe. You have some Ethernet switches that are used for networking. You have the water-cooled bulk power assemblies on the bottom that actually help cool down the machine for really the guts of the machine, which are these processor drawers. There are 5 drawers there. It's a fully loaded machine here right now, and other stuff in there as well. But the important thing that I'm going to be focusing in on here is this thing called the support element. And the support element is really a blade that is running a bunch of code which is used to help in the configuration of the system. And so it's a dedicated workstation basically that's used for monitoring and operating the mainframe. And so again, it's integrated with the same frame. It's right inside the box there. And there's usually multiple ones. If you go back, I'm just going to go back to the previous slide, and you can see that there's 2 stacked one on top of each other there. And that's because you have to have a primary and an alternate so that you can have failover in case one of them is down. Okay, so this piece of hardware is very important because BCPii from a ZOS application is going to be talking directly to this piece of hardware, okay? And I'm going to tell you how that happens in just a moment, okay? But right now, just be aware that when BCPii issues a request to do some kind of automated hardware operation, it's actually talking to this piece in the machine. And just a little bit, how do I interface with that box? Just for fun, I showed some screenshots. So on a Z14, there's actually a arm that comes out that has a monitor display, and it has a keyboard and pointing device right on the unit. In a Z15, they decided to have a different form factor. And so what they do is this is directly from the publications. It's called the Z15 KMM Cubby. So there's like a little place there that stores basically a laptop with a cable that actually connects into the support element. So the laptop is not actually the support element, but it connects to the support element directly there. So people can go directly on the raised floor and actually go on there and actually open the system and actually work there, but most people don't do that in reality. Instead, they use something that allows them to go through a web browser. So on Windows, they have the concept of the control panel, or now they call it Windows settings. That allows you to control some of the hardware configuration on your machine, to set up, to do some setup customized for the machine that you have. On the right-hand side, you have the concept of the same thing, but on steroids, basically the hardware management console, or the HMC. This provides a UI interface to all my interconnected systems that are on the raised floor. They all are in something called the HMC network. And so this next slide, we'll talk just a little bit about the HMC. So this is pretty cool. Again, it acts as a centralized manager for one or more support elements. So imagine in each of my mainframe boxes, I have a support element. So I'll have a support element here, a support element here, and say I have 3 different mainframe boxes, I'll have at least 3 support elements times 2 for redundancy, right? And all of those are in a network. And all those things in the network are managed by the HMC. So the HMC communicates with each of those boxes through that support element. So there's Ethernet switches that allow the HMC to have this closed network that's not accessible to the outside world for obvious reasons, for security primarily. And HMC will direct one or more commands to that SE, okay, which then will issue the commands. The SE will then actually perform the function on that machine. So one HMC can control lots of CPCs, and again, you can connect to the HMC directly via the network in a browser, or actually right there at the HMC console. So there's actually a physical piece of hardware for the HMC in many cases, but you don't have to do that. I can point my browser to an HMC, and the HMC can connect you to the SEs, okay? So HMC is typically a separate piece of hardware. It can be a rack-mounted blade or a desktop option, but on the Z15, it can also run on the SE directly. So this is a new thing on the Z15. Now I can actually run the HMC on one of the SEs on one of my machines, which is really an unusual thing. Okay, so. And again, the connectivity. I have this local area network that's connecting all of these boxes, and the HMC, one or more HMC consoles is connected to that, okay? So this is a hardware lesson, and I'm sorry about that. We're just going to talk about a couple more concepts before we get into BCPii. Once you understand these concepts, then BCPii will make a little more sense. Now, again, from other sessions we've given this week, in an intro to ZOS, we talked a little bit about what a logical partition is, but just again for a recap, a logical partition is simply a way to virtualize a bunch of machines that look almost like their own CPCs. They can have their own processor, memory, and other resources that are dedicated to that machine or that are shared amongst many different LPARs. So again, each LPARs operate independently and can have its own operating system, instance, and applications. And again, one CPC can be carved up into multiple LPARs. Sometimes those LPARs are also called images. So sometimes in the publications you'll see images, sometimes you'll see LPARs. They refer to the same thing, okay? So we need to know that entity because we've dealt with a CPC is the actual frame, the big box that's on the floor. It's carved up into images or partitions. And then we have another thing, the saved configuration, which is when I bring up my CPC, I need to configure it in a certain way. And so I have these different types of activation profiles that will allow you to have a saved configuration such that if I need to re-IPL an image or if I need to customize the resources for an image, I can use one of these profiles. It's a saved configuration. I don't want to have to go every time I re-IPL a system. I don't want to have to specify all of the parameters. I want it saved away so I can just say re-IPL like I always do, right? And it'll just do it, right? So these activation profiles are also entities on the support element. Now, the reason, again, is because BCPii interacts with CPCs, it interacts with images, it interacts with activation profiles. And so you're going to see the power of BCPii, but you need to understand what those things are first because otherwise you're interacting with things you don't have no idea what they are, okay? Are there any questions about the mainframe overview? That's the last slide I have in that section. Okay, great. All right, so now let's talk about what is BCPii. Okay, so this slide we use for pretty much every single BCPii presentation that has ever been given to man. And basically, all you have to know about this is that I have this person depicted on the left-hand side that is basically, there's not a nice way of writing an application here. This person over here wants to actually modify a value in the configuration of the hardware. Okay, so let's say he wants to change a value that's saved in the activation profiles so that when I load the operating system, I am pointing to a different device now, to the code is on another system. Or let's say I just want to re-IPL the image itself. Or let's say I want to obtain configuration data related to the CPC. Or many other reasons. We're going to go into details about all the things you can do with BCPii. But I want to do this in an automated, systematic way. I don't want to have a user having to go over here when something occurs on my system. I want to take immediate action. I want to use a program to do that. Now, these programs have to be quite authorized on the system in order to be allowed to do this because they can do pretty drastic things. Such as, ready for a really drastic thing? You want to be a power-hungry person, get authority to BCPii. You can turn off the actual CPC machine. Turn the power off through your program. That's pretty up there, right? If you had lots of production LPARs running on your system and you turn it off, you have a massive outage, right? So, I mean, obviously you have to have lots of authority to do this. You can also do pretty innocuous things like I want to see what hardware messages are in the log. I can get the serial number of the CPC. I can change what we refer to as processor weights. Processor weights are nothing more than I have a bunch of LPARs that are running, and I want to give a higher priority of to one particular LPAR over another one. So I give it a higher weight. So imagine if I have 3 LPARs that have a weight of 50, 30, and 20, then what you're saying, if I have constraint of resources and I can't all run those things and they all share the same CPs, they all share the same processors, then roughly what's going to happen is 50% of the processing power is going to be given to one, 30% to another, and 20 to another. You don't have to use it in modes of 100. They're just going to take the weight divided by the total number, and that's going to be a percentage of what you're going to get. So anyway, there's lots of things you can do with BCPii. Notice that BCPii doesn't have to can change not just things on the local machine, but I can go to any CPC in my interconnected network and perform these operations, provided I have the authority to do that. Okay? So this is what BCPii does. So, what is it? Well, it stands for this acronym, and I don't like the acronym. So I inherited this because I started out with, there was a BCPii implementation in another product that was really, really, really primitive, but they used that term BCPii, and I said, all right, we'll keep that. It stands for Base Control Program Internal Interface. So Base Control Program is the lowest part of the operating system. It's the part that is probably the most critical, and if there are your problems in the BCP, you have really big problems. Okay, that's like managing dispatching of work on the system. So it's part of that lowest level of in the operating system. So again, it allows authorized ZOS applications to have HMC-like control over systems in that network. So again, if you have the right control, you can do those type of things. Now, it requires both program authorization as well as security authorization. We're going to talk about what each of those mean, because you need to really be authorized to do this thing, probably more than just about anything. Even operating system components within ZOS have to be given authority to it. Even the own operating system sometimes has to have authority to it. So that's pretty intense. Okay? And it also requires authority to the CPC that's set on the SE. So not only do you have to have authority on ZOS, you have to have authority on the support element as well to do those actions. So there's like double sets of authority. So we provide a set of APIs on ZOS that you can actually use. So one of the big selling points of BCPii is it does not use any external network whatsoever. Okay? So it communicates directly to the SE. How does it do that? Do you want to know? At the end of the day, it actually issues a hardware machine instruction to actually give control to the support element. So that's pretty low level. So it actually communicates, it doesn't use any network, so it doesn't use IP at all. Why is that good? Because IP networks are not as reliable as this connection, and so this connection is there. If that connection is not there, your system is toast, pretty much, if it's not there, because you need to be able to communicate to the SE back and forth over this specialized non-network connection. And again, there's an address space too. So there's an address space that that manages this authorized interaction with the internet-connected hardware. And so it acts kind of like a server or a daemon that basically is waiting for BCPii applications to be able to issue those APIs, the BCPii APIs. When it sees an API has been issued, it'll then do the necessary authorization checks. It'll build the request in the form that the SE needs to see it and sends it across to the SE. The SE will process it and move on. I'll show you a diagram in just a moment about that. All right, so let's talk about program authorization. I mentioned you need to have both program authorization and security authorization. So let's talk about program authorization. So an installation is going to identify system or user programs that can use sensitive functions, okay? And the way it does that, it needs to be authorized to something called the application program facility. Authorized program facility. So the authorized program facility, or APF as most people refer to, is a set of applications that we have that the installation has determined that can have the same authority as the operating system itself. Okay, so you're not going to just want to willy-nilly put someone in the APF list. And so the way you do that is you put the library of where that program resides in the APF list. So anything that runs from that library has the authority of the operating system. Okay. So again, this helps avoid integrity exposures. The APF libraries are the only programs that have this type of authority. And again, it's an extension of the operating system. It can do something which we refer to as put it itself in an authorized state. It can go into supervisor state or use a system key. These are all program security protections on ZOS. All I need to say is you need to be an APF authorized program, because of the nature of BCPii requests. BCPii requests are highly sensitive, as we just mentioned before. So once you're program authorized, you can do pretty much anything you want in the system. And in other words, it can even turn off logging to cover its tracks, right? I mean, this is the equivalent of the operating system. So you don't want any program to just be able to use BCPii requests. So what is security authorization? Security authorization is what the security admin uses to give authority to the user. So on top of the need of that program to have like operating system level authority, you also need to have the necessary profiles defined in the system to allow a particular user of that program to be able to actually run it. So imagine I have this authorized program that I'm saying, okay, I'll allow it to have operating system-like authority, but I'm only going to allow one user ID to actually be able to do that. So this is how you would do that. You can accomplish both of those things using the three security products here. So CA, or Broadcom's CA, has 2 of them, and IBM has 1 of them. So these are the 3 major security products that are on ZOS, and all 3 of them support BCPii, and in fact CA is a big user of BCPii for other things, even though we're just talking about profiles here, that you have the ability to define profiles in CA or IBM. And then IBM and CA actually have other products which actually use BCPii to control hardware functions. So it's kind of cool. And again, different authorities can be given for different types of requests. And the authorities can be very granular in nature. So I can give authority only for a particular CPC or to a particular LPAR, and I can only allow them to do read functions, or I can let them do crazy stuff. So again, you need to have program authorization. Is this program an extension of the operating system? It is. Okay. And which users am I going to allow to use that, and to what resources in my hardware configuration am I going to allow them to? And the third authorization you need to have is from your SE. So the person that has the authority to log on to the UI, and actually the admin for your HMC, needs to give authority via that UI to allow BCPii to be used at all, and to give authority to which LPARs can access the CPC itself, and to which LPARs can access LPARs. So what do I mean by CPC and LPARs? So I might not want anyone to be able to do certain activities, like turn off the CPC, to be able to even query the serial number or what levels of microcode. I might want to limit that just to the guy who's maintaining the CPC, but I might allow more people access to an individual LPAR. So let's say I have company A and company B, and they're all using the same machine. So this is what we refer to as a service provider environment, where I have a service provider that owns a mainframe, and he sells LPARs out for lease on his machine, because those companies don't want to purchase their own mainframe instead, but they want to run on the mainframe for reliability, availability, security, all that good stuff, right? So I have company A They have a couple LPARs. I have company B has a couple of LPARs. I certainly don't want company A to be able to look at company B stuff. I certainly don't want B to be able to look at company A stuff. It's probably in the contract that they can't look at them, right? And on top of that, I don't want either one of those companies from looking at things that they have no business looking at. For example, what's the serial number of the CPC? Well, they shouldn't need to know that in any case. They shouldn't need to be able to see what level of microcode is installed on the CPC. So again, you can control which people have access to the CPC itself and which have access to individual LPARs. Okay? Now, prior to a Z14 box, this security was not as granular. You couldn't have this level of granularity that I just mentioned before, where I don't allow LPAR A to look at LPAR B and vice versa. So the Z14 really provided a lot of additional security controls. So again, this is an overview of what the internals of BCPii looks like. So what happens is a user is going to issue a BCPii API, and it's going to be a list of APIs that I'll show you in a little bit to be able to, let's say, to query a value. So they issue HWI query. That's a service that we provide. And that's going to happen is I want to query a particular attribute. So let's take an example. I want to query the processor weight of a particular LPAR. Okay, I want to know what the weight of a particular LPAR is for, let's say, general purpose processors, processors on the machine. So what's going to happen is that application, which has been given program authorization, it has the security. We think it has a security authorization. That thing is going to do what's called a space switching PC. Basically, even though that it's running in the user's address space, the request is going to go into another address space, and that's done through something called a program call or a PC. That PC will come into BCPii, will make sure that they have the necessary authorities by calling the security product and say, this guy is trying to update a processor weight on this particular LPAR. Has the security admin allowed him to do that, him or her to do that? The answer is yes. So, okay, great. Then what happens is we go and build the request, send it out over our transport processing, issue a call to a component which issues the machine instruction. The machine, all of a sudden, the request appears on the support element. Support element says, oh, this is what you want to do, or you want to change this weight. Notice that the support element just blindly trusts BCPii. So if BCPii says to turn off your machine, he says, yes, sir, turn off. So once it gets through BCPii, it's going to do what you asked it to do, right? There's no other checks other than the fact that maybe I'm trying to talk to an LPAR that the SE admin said I can't talk to, right? Something like that. So the request is processed, it gets sent back, and goes right back up, and we give the return code back to the user. So it sounds fairly straightforward. There's a lot of code that's involved to do that, and in a nutshell, the end user just said HWI query for this, or HWI set to set the attribute. So that's all there is to it. So now how do I use this BCPii? Well, there's a number of ways. The first thing is to just be an end user. Don't actually code the APIs, but instead use a feature of ZOS that uses BCPii. So for example, there's ZOS operating system components like parallel sysplex that use BCPii. So you could utilize that functionality. So that's pretty cool. So there's also many software vendors that are on the floor over in the other room in the Solution Center that use BCPii to automate hardware functionality. So there's all those. So again, you can leverage some of those technologies. I'm just going to give you one example from the parallel sysplex because this is what a lot of folks will use to first start using BCPii. So they configure BCPii. We'll show you how that's done in just a moment. But once they configure BCPii, parallel sysplex is a number of systems that are in a cluster for availability of an application, for example. And so when one system goes down in the sysplex, sometimes it takes a while for parallel sysplex to know. Each system sends a heartbeat of I'm here, every couple of seconds. They send this heartbeat. When the heartbeat doesn't appear, parallel sysplex is in a dilemma. They say, well, why didn't I get that heartbeat? Maybe that system's really busy over there and it just got delayed. Maybe they're taking a dump of a problem, which sometimes takes up a lot of resources and they can't not respond right away. So the issue is it doesn't know what's going on over there. But guess what? BCPii may know, because if that system is gotten the equivalent of what we refer to, on Windows they call it the blue screen of death. Do you ever hear that thing when you get that blue screen on your window and basically you're hosed and you have to power the machine off and then power it on? So the equivalent of that in ZOS is something called a disabled wait. If you're in a disabled wait, you're screwed, right? There's no coming back from that. You have to re-IPL your machine, right? So BCPii can detect that condition. So even though he's not getting a heartbeat, so after missing a single heartbeat, parallel sysplex says, BCPii, can you tell me, is that guy dead over there? And BCPii will say, yep. And so he says, oh, it's dead. Partition him out of the sysplex immediately. So that's a good thing to get him out of the sysplex, because that guy may be holding resources that are sysplex wide. And even though only one system is down, all the other systems are experiencing a condition known as sympathy sickness. They're getting sick just because of that other guy who's dead. They're waiting for that resource to be freed so they can continue their processing. Or maybe work keeps getting funneled and sent over to that system when that system is never going to respond. It's better to make a clean, rip the Band-Aid off, per se, and then have that guy's resources freed. So with this, instead of having to wait for about 3 or 3.5 minutes, the average one without parallel sysplex's support of BCPii, it's about 3 seconds. So it's really fast. Yes, question?
If it detects a dead LPAR, will it attempt to re-IPL it?
Okay, so the question is, if it detects a dead LPAR, will it attempt to re-IPL it, right? So the answer is, it can. So it will sys reset the system, which means it releases the resources immediately. And depending on how you have your automation set up, you can do that. So if you have something called Automatic Restart Manager enabled, you can actually have it take a standalone dump. A standalone dump is basically taking a snapshot. If that guy went down with a disabled wait, you probably want to capture diagnostics. So you can have it automatically issue a standalone dump, which will take a dump of the entire address range, and then it automatically re-IPL after that's completed. So there's many funny stories that clients have given to us where they forgot they enabled all this function, and they keep asking, who IPL'd the machine? Because it just was recently IPL'd, and then everyone's playing dumb. It's like, oh, I don't know, I didn't IPL it. And so it's like, well, someone did. And then it's like, oh, wait a minute. And then you found out, oh, no, no one did. It was the system automatically did it. So yes, you can have it automatically come up. And after capturing stuff, you probably don't want to have it automatically come up if you don't have a way to capture the reason, because if you have a disabled wait, that's really bad. You need to find out what's behind that and give that dump to IBM or maybe to another software vendor to help figure out what happened. Okay? So you can also write your own application. So we're going to talk about that in a little bit. So if you decide to write your own application, here are some of the things you could do. I could list all the resources that are available on my machine. I can get the names of all the CPCs that I have authority to. I can get the names of images that I have authority to. So imagine if I'm Coca-Cola and I say, tell me all the names of all the LPARs. It'll give him the Coke LPARs only, if there's another company that's out there and no one else, right? So that's what you want. Only the things that I have authorized to say, okay, there's only 2 LPARs on the system and it's your 2 LPARs, but even though there's 20 LPARs, you only list things that you have authority to. Activation profiles, I can get a list of all the names of all these saved configuration profiles that I have on my system. I can get a list of all the LPAR capacity groups on my system. Capacity groups are a way of being able to group LPARs together for performance purposes. That's all I'll say about that. Once you have the names of these, just using the actual character name, you can say connect to this name. So if the name of the LPAR is A, I say connect to really the character string A. I don't have to know anything else. I can just connect to that exact name that's returned from the list. Once I connect to it, I get back a connect token. That connect token is going to be used on all subsequent interaction for me to be able to query, set, issue commands, and actually look for events. So let's talk about some of the things you can query. So once I have this connect token, now I can say query, I pass that connect token, and then I can specify what attributes I want to look at. So I can look at CPC values, such as the level of microcode installed, the processor configuration. For example, how many of all the engines, all the processors do I have installed in this machine? Very useful to have that information maybe. The operating status of the machine, serial number. I can, for an LPAR, I can find out defined capacity, the maximum capacity I'm allowing this machine to go at for the time being, as well as all the processor weights. I can query all the activation profile values, just about all of them. I can, for LPAR groups, I can find out what are the capacity settings for the group, et cetera, et cetera. There's lots of other stuff I didn't mention here. I can also set a subset of the values that we queried. So you can't set everything, but you can set, for example, processor weights, activation profile values, et cetera. So I can actually just change the values on the fly, just like if I was in the UI and I had the window there. I can actually do it directly from my program. And then I can issue powerful commands. I can re-IPL an OS. I can issue operating system commands. Now this is pretty cool. Z supports multiple different operating systems. There's ZOS, there's ZVM, there's Linux on Z, there's TPF, and ZVSE. So there's 5 operating systems on the machine. I can issue a Linux on Z OS command directly to that. It's agnostic. It just says I'm going to send this string to the console on that machine, whatever it is. So if I can send a Linux command from ZOS to do something. If I want to, I'm going to get the response back from that command, even though it's not even ZOS. So that's pretty cool. I can also register to receive events that when something happens. Now this is pretty cool. These are what we refer to as unsolicited events that occur in the system. I may not have caused something to occur, but something occurred and I want to know about it. So for example, if someone changes the capacity on a particular LPAR and modifies or changes the capacity on a particular machine, I can be notified, whoa, someone changed the capacity. I need to go and do some homework and figure out what's going on. I can find out other things. When a hardware message is issued to the hardware console, I can be notified about that there is a message that appeared on the console. And in fact, they'll tell you exactly what the message actually was, et cetera, et cetera. There's lots of things. When that blue screen of death occurs, I can be notified about that. So, oh, a guy just went to disable wait state. Life is really not good right now for that system. So what am I going to do about it? So, and many, many more. So there's probably like about 20 events I can register for. Any questions on that so far? Okay, so now how do I install and activate it? So we're going to talk a little bit about some installation basics. So first of all, the system is going to try to start BCPii when you're IPLing your machine automatically. There's nothing you have to add in any ParmLib member or any configuration file that says, okay, I want you to start BCPii. It's automatically going to be tried there. It's an integral part of the operating system. But if you don't have the necessary configuration defined, it's going to come down right away because it needs to have the necessary controls that are defined. So you had to have done some setup on the HMC, on the SE to set up BCPii, which we're going to show you in the next slides. You had to set up in ZOS a little bit, not much. And then we're going to set up some stuff in ZOS security authorization as well. Okay, so let's go step by step through this one at a time. So the first thing you're going to do is you have to log on to the HMC as a very special user, a special privileged ID called ACS admin. That is the unique ID that is given to kind of the god that you have that runs the HMC. You might allow several other people to log on to the HMC. This guy is a very special user, okay? He's a privileged user ID. Once you do that, you're going to go into SE management on the left-hand side, and then you're going to select Customize API Settings. And when you do that, you're going to get a nice screen on there which says, okay, I want to enable SNMP APIs, and that doesn't sound intrinsically obvious that that's BCPii, but BCPii actually transforms the request that you make into standard SNMP protocol, and that's part of what the BCPii address space does, is convert a simple API request into this very complicated SNMP string, which has all kinds of very difficult to read stuff, but something that the SE can consume. So I enable it there, and then I have to click on this add button that says for community names, I want to add a community name. So what is a community name? So a community name is nothing more than, the best analogy I always give is a non-broadcasted SSID. So for example, here at the conference, they have a free Wi-Fi that you can specify. There's not even a password that's required here. We're out in the middle of nowhere, right? So there's no need that someone's going to be trying to grab the Wi-Fi and download, stream video or something outside. But if they didn't broadcast that name, I would just have to know the name. If I know the name, I'm in. If I don't know the name, I'm not in. A community name is like the lowest form of security. It's the exact same thing. I can specify the name of the community name, and if I know it, the SE will say, okay, yep, okay, you got the name right. So it's like the password is, and you tell them what the password is. It's such a horrible security mechanism, and it doesn't really do anything. So we always tell our clients there's all these other security measures in place. Just call it BCPii or call it something like that. Typically, clients will put BCPii as the name of the community name. It's just a legacy that's been left over for a long time. They also have to put in for the IP address something called the loopback address, and that it just means that I'm talking to myself, and that's really what it means is when that SE, when we issue that hardware instruction in ZOS, it actually goes to the loopback address and gives control to the SE at that particular address. And you need to say read write on this next option so that in other words, it won't work without the read write functionality. I'll just say that. Once you do that, you finally click OK, and voila, you have a good portion of your configuration already done. The next thing you're going to do is set up the security controls, and this is a statement of Z14 and higher. Z13 we're not going to talk about because that was a very primitive, much more primitive security model. So in this model, I can actually go into systems management and go under the systems detail task on the SE. And from there, I can basically say which partition am I going to allow to actually look at the CPC controls themselves. So remember, in that case of being a service provider, the two companies may not have access, but the service provider is going to have their own LPAR that they're going to say, yes, I have authority to. I'm the freaking service provider, right? So they're going to be given authority. So in this case, they're going to go here and they can enter in. They can, from a pull-down list on the bottom, they can actually specify the partition that they want to give authority to on the particular system, and they can also enter it for pre-planning purposes. They can just enter a name that doesn't even exist, but it will exist by the time I'm running this. So if I want to add, I know I'm going to add another LPAR, I could just add the name right now, even though the LPAR is not technically defined yet. So you have a couple options. Pretty easy. You eventually just click on OK here, and there you go. Now here's the more interesting one, and this in the middle column you'll see a thing called BCPii permissions. It's about the seventh column over. That BCPii permissions didn't exist prior to a Z14, and so what this allows you to do is that is a hot link. If you click on the word disabled or send and receive, for example, for LP01, the LPAR, that's about the fifth row down. If you clicked on that, you would see that it would come up with this panel. And this panel allows you to be able to say what kind of BCPI authority I have. I can either allow someone to actually issue a BCPii API. I'm going to give them a partition, enable the partition to send commands, or I can allow BCPii requests to come into this particular LPAR from which LPARs. So if I have company A that has 3 LPARs on the system, I might say, okay, A, B, and C, those are all one company. A can receive from A, B, or C. B can receive from A, B, or C, and C can receive from A, B, or C, and no other LPARs. And this is done by, again, the service provider. This could also be in a real company that you have your own machine, but you have production and test. You might not want the test to be inadvertently go ahead and issue a very nasty command to your test LPAR, to your development LPAR. So again, you have the authorities and controls to do that. Okay, so that's all I'm going to say about that. You also have the ability to change multiple profiles all in one shot. So they provide a multi-update capability that you can do as well. All right, that's it from the SE's point of view. So now the other setup you have to do in ZOS, very simple. You have to basically, the first step is almost always done by application. You already have this already done, so you don't have to do that. The only thing you have to do is to put any programs that are going to issue the BCPii into the APF authorized library. So you're going to put them into a data set, and then you're going to tell the sysprog, please APF authorize this thing. He's going to ask you all kinds of questions. What the heck is this thing? And he's probably not going to just grant you automatically authority to do that, right? So you have to explain that, and then there's going to be the security on top of this, which is going to say, okay, that's an authorized program, but I'm still only going to allow one person to run it, okay, for example. Then from a security product perspective, I have to define some definitions. The first definition I'm going to define is I'm going to allow this user to use BCPii or not. Doesn't matter what the resource is. It's either an on-off switch that allows this user to use BCPii or not to use BCPii. By default, you cannot use BCPii, okay? So this is an on-off switch. You have to have at least read access to this particular resource, or else you can't even begin to use BCPii. Now, there's another set of controls you also have to have authority, and they say, why do we have both of these? Well, what happens if I have a employee that gets really hostile and whatever, and somehow they can gain access to the system, and they have 25 profiles defined for that user. So what would be nice is if I can just take this one profile, restrict their access on this one profile. It doesn't matter. They could have 100 profiles that they have a lot of authority to. They can't run anything now. So with one change, one command, I can wipe out someone's access immediately. So that's why we have this double set of profiles. So then the next thing they're going to do is then say what resources on my HMC network do I want this program or this user to have authority to issue, to be able to do things against. So the authority level, the profile names are here. For a CPC, you say HWI target dot the name of the CPC. In the case of images or LPAR authority, I'd say HWI.target dot the name of the CPC dot the name of the image. So if I have a CPC called, and there's a dot in between, so let's just call it A.B is the name of my CPC, and the image is C, I would say HWI target.A.B.C, and I'm going to give them this kind of authority, depending on what request, what kind of API they're trying to use. If they're just trying to read something, I'm going to give them read authority. If they need to update through the set command, I'm going to give them update authority. If they're trying to do those really powerful things where I'm issuing operator commands or I'm re-IPLing or doing these really other things, I need control authority. So there's levels of authority. The more authority that you have, the more APIs you can issue. And finally, I have to define that community name. Remember the community name, that non-broadcasted SSID-like thing that I defined on the SE? I now have to associate that and put that into the RACF or the security product. Why? because whenever BCPI interacts with the SE, it needs to know what that community name is, but BCPI has no idea what you filled in on that panel. So you're now telling BCPI, and by the way, this is the secret handshake, right? You just type in, this one's the most non-secret of all, right? It's just the word BCPii. You have to fill it in here, okay? And you have to repeat that for every CPC that you interact with. Most people name all of their community names the same on all their systems, so you could have like a wild-carded thing here and say HWI target.splat.splat, and then that would basically allow, that's saying the community name for every single interconnected thing I have is the same, and the name is BCPii. So that's what you have to do. Okay, so that's how you install it. Once you do that, you can start. How do I maintain it? And so we're going to talk about the address space now, stopping and starting it. So I'm going to actually, again, try to start BCPI when IPL is occurred. So that happens automatically. If it didn't come up for some reason, I can start it after the fact. I don't have to actually re-IPL. So I can say, okay, and now I think I have all the configuration done. So this is great. You have a live system running on your shop that doesn't have BCPii up. You don't have to re-IPL. You just simply have to do the steps that I told you and now say start space HWI start from the operator console. If everything is successful, you will get a nice message that says HWI001I in your console log, BCPii is active. Those are the magic words. That means I can connect to the local CPC at least, and you've defined the definitions at least for the local machine. I might have a problem when I connect to some remote machine if I haven't set other things up, but I know I can connect to the local system. I can also stop the address space at any time. This could be for like emergency maintenance on the machine. I need to apply maintenance and I don't want to re-IPL. I can probably, most of the modules in BCPI allow you to not have to re-IPL the machine. So that's very important. We don't want an outage. This would just be a short outage for BCPI itself. And by the way, when you start or stop BCPI, you can register with a services called Event Notification Facility, ENF. And what that will do is whenever BCPI started or stopped, it will tell ENF, it says BCPI started, and you get an event. And then you can actually say, oh, okay, great. Now I can start, I'll try to connect to BCPI now. And then if you get the event that BCPI goes down, you can say, oh, I should probably not use BCPI requests because they're not going to work, right? Okay. All right, so good. Now, how do I check the status of BCPI? The way to do that, there isn't really any console command to check it, but you can do a couple of things. You can go look at and see if the address space is listed in SDSF. You can also check to see that the message BCPI is active is in your log. And if you invoke an API that when BCPI is not active, you're going to get a FOX00 return code, which basically says HWI not available. It means that the address space is not on. So this is just a screenshot of some messages that you see when BCPI is trying to initialize. This is very early in an IPL, and you'll see that message right in the middle, HWI001, BCPI is active. You see that one, life is good, at least for the local CPC. Now, how do I debug BCPI API errors? So we have a whole multi-session thing about programming, and this would be how to do more programming. But from a systems programmer point of view, or how do I actually, if I have an application programmer that's having a problem, what can I do? Well, the first thing, the application programmer is going to get a set of return codes, and there's a diagnostic area that they can look at. That's the first step when you have a problem. Look in the unique return code in conjunction with the diagnostic area, which may contain some text that explains what actually happened. That's the first thing. If you're having problems beyond that, you as a system programmer, for example, could turn on BCPii ctrace. Ctrace is a tracing facility on ZOS that allows you to set a lot of cool functions. And once you do that, I can now rerun my program, turn the tracing off, and look at the output of that, and there'll be a lot of good stuff. There's also sometimes symptom records. Symptom records are captured in a data set called logrec, or in a log stream, the logrec log stream, and you can actually get more information there. And lastly, for debugging, there's also something called support element tracing. On the support element itself, it traces a bunch of things of interactions between you. It can trace things at a higher level. You can just see the APIs that are flowing in, and you can also trace at a lower level to see every single little part of the SE of what it did for that particular request. So there's lots of information, and sometimes you want to debug from both sides because you might get this thing where, you know how it is, he said, she said type of thing. No, I sent it. No, you didn't. And so you can prove it, you know, one way or the other, where the problem lies. Okay? All right. So for reference material, there's a bunch of places to go look. This very first book, and here's the point that I made about, remember how we still use the word MVS? Here's a good example. ZOS 2.4 MVS programming, callable services for high-level languages. That's telling you that this book is documenting things that are in the base of the operating system, in the actual core, the BCP. Okay? So that book on the very top has about 95% of the documentation for BCPii. Okay? So if you look in that book first, you're good to go. These other ones have little bits and pieces, like for example, that we have a start and stop command, so you can learn about those particular things, but the vast majority of information is in that programming callable services book. There are also lots of user presentations and IBM presentations that I'm giving. I just used the United States Share Conference as an example, and look in the last year how many unique presentations were given about BCPii in those conferences. So we had the 2.4 update here as well. I gave that earlier in the week, right? But we have advanced programming. We have a 2.3 update. We had hardware management, console security basics. All these sessions had at least like multiple slides on BCPii. They didn't just use the word BCPii once on a slide. They had multiple slides. And some of these are by vendors. A survey of Sysplex recovery mechanisms, combining BCPii functionality and REST services to drive ZOS value. A DR test a day keeps downtime away. Using Hitachi mainframe recovery manager, nothing to do with IBM. This is a vendor that Hitachi, right? And ZOS V2 R3 user experiences. Just since March 2018, lots of presentations. And now we go to the opposite extreme, way back in 2013. One of the premier consultants in the world for ZOS, someone by the name of Cheryl Watson, she has a tuning letter which has a very huge following. And she is an authority on ZOS in general. She wrote a probably 12 to 13 page article back in 2013. If your company has a subscription to this, you can gain access to it. It's not a cheap subscription, so it's because she gives very important tidbits. And I would say there's a lot of people that subscribe to it, so you might be able to get that, and that has a really good articles on that. We have hot topics articles that we had, and many other places for information. And of course, you can always contact me, and anyone who wants contact information from me, I'm happy to give you my business card. And with that, I'd like to ask, are there any questions? We're just about on time here, so I just wanted to know what questions you may have. Yes?
What was the inspiration for the product? Was it a client requirement, or was it how did it come about, if that makes sense?
Oh, why did BCPii come into existence? Okay, that's a very good question. So I would say BCPii came into existence because there was a need for clients to, well, we knew that vendors, a lot of vendor products, had no real way of automatically looking at hardware stuff. And so we were initially writing this for some IBM internal products and for maybe possibly for vendors to be able to have access to the hardware to do automation type of things. We never anticipated that we have many, many, many clients that wrote their own applications. And how do we know that? Kind of an embarrassing way, because they opened up a problem record with IBM. Used to be called PMRs, now they're called cases, right? And the case basically tells I was doing an HWI service, blah, 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 and I had a problem. So we hit a sweet spot and it went off like wildfire. When this came out, there's not a lot of components that have this amount of embrace right away. So I guess the need to just be able to do things in a more autonomic way instead of relying on an end user having, when I need to re-IPL the operating system, I don't necessarily always want to have to go into a UI and click a bunch of buttons. I want to be able to do it instantaneously in certain circumstances. So there's lots of use cases. I have a session that's called How to Make the Most Out of BCPii, and it talks about a lot of the use cases for how clients use it, and that's very interesting. But that's another time. I actually did that last year at the GSE. So, but anyway, I thank you for your time. If you take a moment and fill out your evaluations, we really would appreciate it. But I thank you for being very patient on the last session of the day, and if you, now you can enjoy the rest of the evening. I would also encourage you to consider if you have want to embrace some new technology in any way, to check out the Client Experience Center for free workshops that we run, and I can be glad to fill you in on any of that information. So with that, thanks a lot, and have a good rest of your conference.